In the last lesson, I said I was going to do internationalization next, but I found out that the method to do that has changed a bit. So that's going to be put off until I can learn the new method. So for this video, I'm going to show how to clean up some of the inventory functions. Right now we have a lot of the inventory functions just embedded in the player class. We're going to pull that out into an inventory class, and we're also going to do something called functional programming. It's a slightly different style. You might have heard of it if you've looked at F# or Haskell or OCaml. And one of the things about functional programming is that the objects are immutable. You don't change the properties on an object. Instead, you always instantiate a new object with the changed values. Now, constantly creating new objects, new instances of the inventory object, will be a little bit slower than it would be if you were just modifying existing properties like we do for the inventory list property. But with a game like this, we're not going to notice the speed difference, and what it is going to give us is something that is much more testable. Right now, if we want to test anything out with the inventory, we need to instantiate a player object and start giving things to the player. With a separate inventory class, we can just instantiate an inventory object, modify what's in it, and get the results back. This may not be clear right now, but I think if you follow through the code and see how things work at the end, especially when we do the unit testing, it will start to make some more sense. The first thing we'll do is open up the solution and go into the engine project in the models folder and create this new inventory class. Now in this one I added some of these regions with region and end region. If you haven't seen these before, it's just a way to designate in a class what you're doing in that particular area of the class. We don't really need this. It's a 86 line class, and that's with the region and end region lines. But I put it in because it might be a little bit clearer since we're introducing a new concept. In the region from 9 to 17, we have the backing variables. We have a list of game items, which is the backing inventory, and we have a list of grouped inventory items. This is the list that we use in our data grid so that we can say that you have 5 snake skins instead of having 5 individual snake skins listed in the player's inventory. In 19 through 34, we have the new properties. These should look pretty familiar. They're basically what we had in the player class before. We had our grouped inventory, our weapons, our consumables, and our has consumable property. What we've also added here is an items property, because we need a way to actually look at what items are in the inventory now that we have this separate class. And you may notice that everything is being returned as iRead-only list. So here for the items, we're returning the backing inventory as read-only. This is where we have the immutability of the class. You can only read the items in the grouped inventory and the weapons and consumables. You cannot modify any of these values from outside the class. Then we go to the Constructors region, and this is where the real heart of the functional class is. Whenever we want to change something, what we're actually going to do is create a new inventory object with the new list of items. So if we want to add an item to an inventory, we'll say create a new inventory with the existing items from the old inventory plus the new things we're adding. Or we can say create a new inventory object with a list of the items from the previous inventory object, except we're going to remove a few items if the player sells something or trades something or crafts something. And you'll notice in the constructor we have the parameter of items, which is an IEnumerable of game item. And we've got the equals null, so if you don't pass in a parameter, this will be treated as null. The first thing we do is check to see if the items is null. If nothing was passed in, then we just return with a new inventory object. But if the items parameter was not null, we're going to loop through it, and we're going to add the item to the backing inventory private variable, this one up here, our list of game items, and we're going to call the add item to grouped inventory function, which is a function down here on line 67, and this is where we just do the Same logic we had in the player class, where if the item is unique, like a weapon, we add it as its own individual item. But if it's not unique, like a snakeskin or some consumable, then we're going to look and see if that already exists. If so, well, if it doesn't, we'll add it. If it does, then we're going to increase the quantity by 1. So that's all that the constructor does, and that's where everything gets changed by constructing a new object with a slightly different list of items. And down on 55 through 62, I added a public function, has all these items where you can pass in a list of items. This is basically acting like a property, but it needs to take in some input parameters because we're going to see if the player has a list of these items for completing a quest or making, crafting an item. And that's what this function does. All it does is it returns a bool. Yes, the inventory says we have all these items, or no, we don't. And if you look in the old player code, one of the things we had to do when we changed the inventory is we had to raise property changed notifications for the weapons and the consumables and the has consumable. So that way the UI would know that something changed with the inventory and maybe the player has different weapons or consumables or not. Because we now have this inventory object, what's going to happen when we add something to the inventory, we'll create a new inventory object with a new list of items in it, and we're going to replace the old player's inventory property with this completely new inventory object. The nice thing is when we raise the property changed notification for the inventory object, then the UI knows it has to change any of these, the weapons, consumables, has consumable, that it was binding to. You'll see more of this when we get into the living entity class, which is where we were managing the inventory for the player and for the monsters. The nice thing about this is if we ever create a new property, like let's say alchemy ingredients or armor or jewelry, we can just create a new property here where we check to see if the items are a particular type of item, a piece of jewelry, a piece of armor. And when we update the inventory object, the UI will automatically know to refresh its list of armor items or jewelry items. Now that we have this new inventory class, we need a service to actually do the adding and removing items. So we created this new engine services inventory service class. It's a static class, and we're treating this kind of like extension methods. These are static and they take a this. So when we need to change a player's inventory, we'll be able to say inventory.addItem, and then we'll get back a new inventory object with the modified inventory list. And I've just created a few different ways to add and remove items. For instance, here you can add an item to the inventory and you can add a game item. I've got an add item from factory where you can pass in the item type ID, and we'll go and instantiate an item of that item type ID and add that item. And then I've got another add items here where you can pass in a list of game items. And then finally the add items function that takes in a list or IEnumerable of item quantities. So if the player gets 2 snakeskins or 5 rat tails or whatever it is, we can use this one. Basically what all of these do, most of them just call this particular version here on 24 for the add items, is it takes the current inventory, its list of items, and concatenates whatever list of items we're passing in. So if we said inventory.add items, and then we listed a granola bar and a new sword and a new stick, eventually we would get to this function and we're going to add that list to the existing items, and we're going to create the new inventory object passing in the modified list of items, which if we go back to our inventory class, it's going to go through our constructor and build a new object, and populate the backing items and kind of cascade everything down to the weapons, consumables, and so forth. For the add items, it takes in a IEnumerable of item quantity. We just create a new list of items to add, loop through the items quantities passed in, and then we're going to add however many items from the factory that we need to create and add to the list. And then we're going to call return inventory add items with this new items to add. So it goes back to this version on 24, where we instantiate the new inventory with the modified list. For removing items, it's pretty similar. If we call .remove item and pass in a single item, we convert that to a list with just that one item so that we can go through this version of remove items, which takes an IEnumerable of items. It builds a working inventory, whatever items are currently in the list, and then starts building a list of items to remove. It removes those from the working inventory and then instantiates a new inventory with the working inventory. So if the player had a pointy stick and a rusty sword, and we said we want to remove the rusty sword, we would probably call this remove item with rusty sword. We'll make a list that just contains that rusty sword and call this particular version of remove items. We're going to get the player's current inventory, go through the items to remove, and take out the rusty sword, and create a new inventory with just what's left in the inventory, which in this case was the pointy stick. We also have this remove items function that takes in an IEnumerable item quantity, which will loop through the item quantities, remove those from the inventory, and return the new working inventory that was created. And on lines 85 through 89, I've got an extension method, items that are, and takes in a game item category. We just use this for checking to see in the inventory class for our weapons property, items that are weapons, or items that are consumable for our consumables property. This really doesn't fit in with the other functions we've got in here because it doesn't return a new inventory object, but I didn't want to create a new class with one extension method for the new inventory object. So if we expand this in the future, we'll probably pull this out and put all the inventory extension methods in one new inventory extension method class and just leave the service ones in here. But for right now, this is okay. Now that we have a nice clean inventory class and an inventory service class, we can go into our living entity class and remove all the old inventory management code. We'll start by adding in the using engine services so we can use the new inventory service. And next you can go into the inventory properties, which if I use GitHub to show me the difference, we'll see are down by line 112 through 123. It's all these inventory, grouped inventory, weapons, consumables, and has consumables. And in its place, we're going to add in on line 18 this new private inventory underscore inventory. This will be the backing variable for our new inventory property. On line 70 through 78, we've got the new property with the getter for the backing variable and a private setter and the on property changed. This is a private setter because right now we want the only thing to change the inventory to be this living entity class. We want to kind of lock it down so it's not changed from everywhere. Then we'll go into the constructor for the living entity class. There used to be setters for, if we look at the code, we used to have an inventory equals new observable collection game items and grouped inventory equals new observable collection grouped inventory items. And instead we're going to delete those and replace it with inventory equals new inventory. This will instantiate a new inventory object and set that to our inventory property that we just created. And then finally, we're going to go down to our add item to inventory function, our remove item from inventory, our remove items from inventory, and our has all these items. And we can delete the has all these items function because that's now in the inventory class. And all the logic that used to be in those add item to inventory, remove item, and remove items from inventory, we're going to replace with one line. So our add item to inventory now just says inventory equals inventory.add item with the game item. What this will do is this will call the add item extension method over here in our new inventory service, convert that item to a list, call this root function, get the current items out of the old inventory and add in the new item, and create a new inventory object and return that. And we're going to populate the inventory property in living entity with that new object, which if we go back up to the property, we'll raise the property changed event. The UI will say we have a new inventory, I have to refresh things, and I have to refresh all of its properties. So now all of our inventory management in this living entity class is replaced with one line for each of the functions. I think we can clean this up a little bit more in the future, but I think this is a good step, a good first step. And that's most of the heavy lifting for this particular change. The rest of it is going into the UI and the other classes and using the new inventory property instead of the old inventory property. We'll start by going to the game session, and on line 127, before we had if not current player weapons any, and now we need to have if not current player dot inventory dot weapons any. For any of you using some sort of source control, you can always do compare with unmodified, and it will show you the original value and the new value. So here all we're doing is changing on line 127. On line 185, we're saying if current player dot has all these items, we change that to if current player dot inventory dot has all these items. On line 284, same type of thing. If current player has all these items to complete the crafting, we want to change that to if current player dot inventory dot has all these items. And then on line 338, when we get the loot items from the monster after defeating it, we're going to say for each game item in current monster.inventory needs to change to for each game item in current monster.inventory.items. And that's all the logic change we need to do. Now, something I mentioned at the beginning was that the functional programming is kind of cool because it's immutable and it's kind of self-contained. One of the ideas is that you don't need to have a lot of setup classes or rely on things outside of the object, which makes it a lot easier to create and run unit tests. So I created in our test engine project a models folder and a test inventory class. And make sure you get all these using statements because we need to get the engine factories, models, services, and the unit testing. But what these tests do, this first one instantiates an inventory and checks that our items count is 0. Next we add an item, so we instantiate an inventory. We say inventory.addItem from factory 3001, which we'll call the extension method in the inventory service, return a new inventory object, in this case we'll call it inventory 1, and then we check that the item count for inventory 1 is now 1 since we added an item to it. Then we test adding items, where we create a list of game items, add that in through the inventory service extension method, and check that the modified, the new inventory 1 items count is equal to 2. Another cool thing you can do is since the add items, this inventory.add items returns an inventory object is you can chain these. So this, at this point, is another inventory object. And if you see down here on lines 47 through 50, we say inventory2 equals inventory1 dot add item from factory, and then dot add item from factory 3002. So this is returning a new inventory object, which we can then call the add item from factory extension method on again. And we can just chain that into a nice long list if we want to. The rest of these functions work pretty similar. We're just testing the different variations of whether we're going to add item quantities or items, testing removing items, testing that our weapons and consumables gets properly populated when we add weapons or non-consumable or consumable items to the inventory, testing that we can remove item quantities, and testing that if we try to remove too many items from an inventory, we get an exception. That's what this attribute here for the test says, expected exception, type of invalid operation. So if we try to, in this case, we add one 1001 item, 4 1002 items, and 2 3001. We check to make sure that the quantities are what we expect. And then we try to remove 999 1002 items, which there's only 4, so we do expect an exception. Now if I run this, since I have ReSharper, I have something called cover unit tests. So this will run the unit tests. And here I see test inventory, everything's green, it all passes. But I can also go into the unit test coverage. I can go into the engine, check my services and my inventory service, and you see over here the coverage is 100%. So I know 100% of our functions are tested. This makes it pretty easy to make a change, because if I make a change, I run my unit test, I should know if I broke any existing behavior. And that's the nice thing about this functional object that doesn't need anything else. We were just instantiating an inventory object. We didn't need to instantiate a player object and do any setup for the player that we might need to do. The final things we need to do for this change is make the associated binding changes in the XAML. Since we kind of messed around with the players and the traders inventory, we need to go into mainwindow.xaml. And again, I'm going to show with the unmodified, the original code. So what we did is on line 172, we used to bind, this is the player inventory data grid, we used to bind to current player.groupeddInventory. We now need to bind to current player.inventory.groupeddInventory. On line 274, we have the combo box for the player's weapons when they're attacking. We used to bind to current player.weapons. That now needs to be current player.inventory.weapons. On 284, we had the consumables, the granola bar. We used to bind to current player.hasConsumable for the visibility. And now that has to be current player.inventory.hasConsumable. And we bind the item source is now going to be current player.inventory.consumables. And then 290, we just need to bind to current player.inventory.hasConsumable for the visibility of the use button. If we go into the trade screen and look at its differences, on line 40, where we were binding to the current player's grouped inventory, now we need to bind to the current player.inventory.groupeddInventory. And then on line 75, we need to bind to the current trader.inventory.groupeddInventory. Now that we've done all this, let's run the game and make sure that it actually works the way we expect it. Here's our standard inventory. We have our consumable granola bar. If I use it, the consumable drop down and use button disappears, and we saw the inventory got updated. If I go into my recipes and craft a granola bar, we see the consumables comes back, and we see the inventory updated. The raw ingredients are gone, and we now have a granola bar. If we go north and we fight a snake, we're collecting snake skins and snake fangs. If we go to a trader and I sell my snake fangs, we see the trader's inventory increases, and we saw the player's inventory decreased in both places. If we buy, the player's inventory comes back. So it looks like it's all working. This was a kind of big change, and it's a little different way of thinking. So it's a kind of thing you might need to go through the code once, kind of see how it works, maybe set some breakpoints in the inventory service or maybe in the living entity class. If you set some breakpoints when we add items and remove items, and then you use F11, when you hit the breakpoint, you can kind of step through the code and see what happens. That might give you a better idea. But this is a really cool concept that will let you build more stable programs, more easy to test programs, since the objects won't touch a lot of resources outside of themselves. It's a lot more stable, and you don't have some of those weird side effects you see. So I think it's a good thing to add to the program, and it's a good thing to know how to do. As always, in the description below the video, if you're watching this on YouTube, I'll have a link to the support page with all the source code, and to the GitHub repository, and to the project plan. If you have any questions, please leave a comment on the support page on my site or here at the YouTube video, and I'll get back to you as soon as possible.